Okay, welcome. This is part 3 of solving systems of equations by matrices. We're in chapter 12 in the textbook. Part 1, I think we finished up the algebraic solution, and then we did the theory using matrices. And part 2, we did some extensive notes on row reduction and what that means, and row echelon form. And we also spent some time on one or two large examples. Today, right now, what we're going to do is this will be our third, this is part 3 of solving systems of equations by matrices. And we're going to spend time on the classwork and the homework problems which were posted on Blackboard, and the solutions are posted as well. Okay, so let's go step by step. And here we go. So, classwork, first question. What does the given matrix in row reduced echelon form tell us? And what I neglected to do here is I should have had a bar here which separates the x, y, z, the equations from the actual constants. So let's go right now to the solution and let's take a look at it. Okay. So we got this concept called a matrix, and what a matrix is, it's just an array of numbers, a rectangular array, where we save some space, and we do not put in the x, y, z, we just assume that everything is lined up properly. So again, I've got to emphasize that's really important. When we have this matrix tableau set up, everything here are the x's, here are the y's, here are the z's, and here are the resulting values. So the first row is first equation, second row is second equation, third row is third equation. And we're allowed to use certain applications of what we do to the rows. We're allowed to interchange rows, we're allowed to multiply one row by a constant, and then we're also allowed to multiply a row by a constant and add it to another row. Okay, so these are the permitted operations called row reduction, and their purpose is to end up with something called row reduced echelon form. So here's an example of row reduced echelon form, and what we're basically going to do is we're going to reaffirm what that means, and it means that you have ones on the main diagonal, okay, zeros below, and other stuff elsewhere. Okay, that's row reduced echelon form. So the next question is, well, so what? What does it mean? How does it help us? And what we do is we realize that if we go to the equation form, but in other words, putting the x's and y's back, you get something interesting. You get that the last row, which models where we are with the third equation, just says z equals 3. Well, that's good, right? And this would be the second row. Notice there's a 0 here, meaning you have no x term, and this would be the first row in the first equation. And once we get z equals 3, we can backward substitute and get the other values very easily. So in other words, here I'd substitute z equals 3 into that second equation right here, and you get y plus 6 equals 5, so y is negative 1. And then you'd backward substitute both z is 3 and y is negative 1 into the first equation, right? And you get this, you work it out a little bit, and you get x is 4. So x, y, z in alphabetical order, 4, negative 1, 3, parentheses, meaning it's a point in three-dimensional space, and the brackets mean it's a set, it's the solution. That's rather easy to do if the matrix has been put in row reduced echelon form. So that's why we do it. And let's look at a few examples. I'm not going to do all the ones from the classwork. I'll go and do one or two from the homework worksheet as well. And again, all the solutions are worked out in Blackboard if you can read my chicken scratchings. But okay, so let's look at example 1. first of all, you'll notice there are no x's and y's in it, there are r's and s's. No big deal. The idea is that when we go to list our or write our solution, if there is a unique solution, you go in alphabetical order. That's the key. So R comes before S in the alphabet, so -2 would be the R value and S would be 5. Okay? And that's all you got to remember. All right, now the idea is, of course, these things have to be lined up properly, or else taking away the R's and the S's just leads to confusion. I mean, it's sort of like if we write the number 3, 5, we mean 3 10s and 5 1s, or 35. We don't write 3 times 10 and plus 5 times 1. We could, but instead we have a place value. Well, this is like a place value. And that's what we're doing. It just makes things a little bit easier. We do the same type of thing in synthetic division, which you learned in pre-calc 1. Where we can divide a polynomial by, an x plus or minus a, something of that form, and basically you just got to make sure you have zeros for missing terms, and otherwise you don't write in the x's, you just write in the coefficients. That's what we're doing here. Okay, so 3r plus 2s is 4, 3, 2, and a 4 here. This bar indicates that this is where the variables live, and this is where the constant on the results, the right side equal sign, and once again, everything has to be lined up. So the R's have to be vertically aligned, the S's, the constant numbers, and important too, the equal sign. So if you had an equal sign over here, you have to move some terms around or apply this process. Okay, so step 1, you want the upper left-hand corner to be a 1. So that means I'm going to divide everything in the first row by 3. So that's the rule that says it's a row operation. You're allowed to multiply or divide a row by a non-zero constant. So I divide this by 3, get a 1. This by 3, get a 2/3. This by 3, get a 4/3. Okay, so now I've got a 1 here, and the idea is I want to make this position a 0. Well, how do I do that? I imagine I still have a 1 here, and if I have a 5 here, I have to multiply this by -5, every one of these, and add it to the corresponding elements here. So this times -5 is -5, added to 5 is 0. Okay? This times -5 is -10/3, added to -3/3 would be -13/3. And this multiplied by -5 is -20/3, added to -45/3, right? LCD gives us -65/3. So now this is almost in row reduced echelon form. I've got a 1 here, a 0 here. What I'd like to see here is a 1. Well, how do I make that a 1? I divide by itself. So I'm going to divide every one of these elements, and of course 0 divided by a non-zero number is still 0. I'm going to divide by -13/3. So I divide this by -13/3, get a 1. This divided by -13/3, you'll invert multiply, you get a 5. So now this matrix is in row reduced echelon form. The main diagonal is a 1. Below it I have zeros. And then what we're going to do is we're going to transform this. We're going to go back to the world of variables. This becomes s equals 5. And this equation is r plus 2/3 s equals 4/3. So I'm then going to go and I'm going to substitute in. But easy way of substituting, I mean, I could substitute into here, would be fine. I could also substitute back into row 1. Okay, so I'm going to do that. That appears what I did, because I now know s is 5, right? So I go back in, and I put in s is 5, so I get a 10 here, and 3r is -6, r is -2, so I'm done. Okay, or I could have been a purist if I wanted to and substitute it into here, right? I have 1r plus 2/3 s equals 4/3, and in place of s, which I got up here, I'm going to put in a 5. So I have to do some arithmetic. So I think a good way to handle this is to multiply everything by 3, because this is the bottom here, it's the bottom of the fraction here. This is r over 1, so 3 is the LCD. So if I multiply each of these 3 terms by 3, I get 3r I get 2 times 5 are 10, and I get a 4. So I get 3r plus 10 is 4, 3r is negative 6, r is negative 2. That gives us our solution. Okay? All right, so let's look at, I guess we'll go and look at the last one. That's the most complicated one. Okay? Most complicated one. All right, so here is our system of equations back in the world of x, y, z. And all right, so this becomes 3, negative 2, 3, negative 3. This becomes 1, 1, 1, 1, 4, 1, negative 4, 2, negative 9. And since we want to start with a 1 in the upper left-hand corner, I can choose either one of these and put them and change the order. So what I did is I put this equation on top. All right, that's the rule that you're allowed to interchange rows. I mean, if I'm moving the equations around, I'm not doing anything. I'm still going to get the same solutions, right? So I put 1, 1, 1, 4 on top, and I put the 1, negative 4, 2, negative 9, which is from this equation, second, and this guy I put third, okay? So now I want this to be a 1, and it is. So I'm going to use that to make the rest of these zeros. So what do? I multiply this guy by negative 1. I actually do that mentally. I keep it written down here, but I mentally multiply these by negative 1 and add them to equation 2. So this is negative 1 added to 1 is 0. Negative 1, I'm multiplying by negative 1 now, added to negative 4 is negative 5. Multiply this by negative 1, I get negative 1 plus 2 is 1. Multiply this by negative 1, that's negative 4, negative 4, negative 9 is negative 13. So now what I've done is I've made this element a 0. My goal is row reduced echelon form. Now I'm going to work with the original, with my top equation, and I'm going to try and make this a 0 and put the results here. Okay, so well, if I want to kill the 3, I'm going to multiply all of these guys by negative 3. And again, I'm not really changing it, so I'm multiplying it in my mind. So in my mind, I'm seeing a negative 3, negative 3, negative 3, negative 12 here. Okay, so negative 3 and 3 is 0, so that's a 0. Negative 3 and negative 2 is a negative 5. Negative 3 and 3 makes that a 0. And negative 3 times this is negative 12, added to negative 3 is negative 15. Okay, almost there. Okay, so I'm looking for row reduced echelon form. So I want the main diagonal to be a 1. So this is already a 1. These guys below is 0. So I'm going to work on right here. Okay. Now what I decided to do, what did I do actually? Yeah, it looks like what I did is I reversed these two rows. For the simple reason I knew I wanted to divide this by negative 5, and I didn't want to have to divide this by negative 5, so I chose to work on this row for the simple reason that, 5 goes into 15. I want to avoid fractions. So this I'm going to move into my second row, divided everything by negative 5. So this 0 and this 0 are unaffected. This becomes a 1. Negative 15 divided by negative 5 is 3. So that's my second row. And this moving down to my third row, because I'm allowed to interchange rows. So okay, so I've got my 1s here. The only last step to make this in row reduced echelon form is I want this to be a 0, because everything below the main diagonal is supposed to be a 0. So how do I do that? Well, I'm going to use this equation, and in my mind I'm going to multiply by 5 and add it to this equation. So 5 times 0 is 0, add to 0, unchanged. 5 times 1 is 5, added to this makes a 5, so 5 negative 5 is 0. And this, of course, is unchanged. 5 times this is 15, added to that is 2. So this is what I end up in when row reduced echelon form. So again, here we go. You got the diagonal, the main diagonal is all 1s. Everything below it is 0s. All the other stuff is something else. Okay, so let's look. X, Y, Z. So this means Z equals 2. Great. This means Y equals 3. That was even easier. So then I'm going to simply plug in y is 3, z is 2 into this equation here, which is x plus y plus z equals 4 is my old second equation. I plug it in, x is -1. So putting the letters in the values in alphabetical order, I put the x, the y, the z, I get -1, 3, and 2. Okay, so that takes care of some of the classwork problems. And there are others, of course. So, we did 0, 1, and 4. You should do 2 and 3. I mean, I picked the interesting ones with the different letters and a little talk in here, and I picked the 3 by 3. You should do the rest. Okay? If you already got it, then you don't need it. All right, so I'm going to close that one out. I'll close this one out. And let's look at, these are some of the homework problems that I suggested. And again, I'm not collecting these. The ones I'm collecting, that's already up on Blackboard. So I guess we'll look at one or two of these. So let's do this one because it comes out to fraction. And also let's do, I don't know, maybe we'll do 3, the more difficult one, because it's a 3 by 3. Okay, so let's do 3 and we'll do 5. I'll save the others for you folks to try. Okay, so number 3. Here's number 3. And let me just check my work to make sure I'm put the numbers in correctly. All right, this was x plus y plus z equals 4. This was x minus y plus 2z equals 1. And this was x minus y minus z is -2. Okay, so I did that correctly. And you're going to notice that since these were the homework problems, I took a little more care as far as writing down and notating what I was doing. All right, so these little notes here tell me what I was actually doing. The other ones, the classwork ones, if we had like a face-to-face class, I probably would have done them on the chalkboard and giving you the explanation. But so these are homework, so these are a little better explained. Now, something you might be thinking of as well is, why am I going from top to bottom? Why am I not going from left to right? I mean, so I'll tell you, for some reason, when God created human beings, He gave us the ability to more easily check if we have any typos when we work in a vertical as opposed to working horizontally. That may be cultural, I'm not sure, but in other words, it's easier for the human eye. For some reason, I found this over the years. I've been teaching for several decades, several decades, and I found out that, let's suppose I'm looking at this second equation. I got 1's and 2's, I got a 1 negative sign, and it's easier for the human eye to keep track of working down than it is working across. So when I'm talking about multiplying the top equation by -1 and then adding it to the other equations to make these elements of the matrix 0, it's easier to work vertically. Now, maybe back in elementary school, we would write 2 plus 3, one on top of the other, and maybe that's why we've trained ourselves to be a little more careful, a little more understanding, working vertically. But I've just found that, I mean, you can do this horizontally if you want, it doesn't matter, but students make less mistakes, not math mistakes, but less copying mistakes, working top to bottom. So do what works for you. Okay, so again, my goal here is I want to have 1's on the main diagonal. Upper left-hand corner is already 1. I'm going to leave it. I want this guy to be a 0. So mentally, I'm multiplying these by -1. I'm going to add them to the second equation. So -1 and 1 is a 0. This is -1. Add to -1 is a -2. This is a -1 added to 2 becomes +1. And this is -1 added to 4 is -3. That's how I got that. I'm going to do the same. Now, since I have a 1 here, I'm going to do the same thing. I'm going to multiply this in my mind by -1, add it to the third equation, term by term. All right, so -1 and 1 is 0. Negative 1 is negative 2, negative 1 and negative 1 is negative 2, negative 4 and negative 2 is negative 6. Okay, I'm now down here. And look at what I did. I wrote down how I went from this step to this step. It says add negative R1 to R2 and R3. So that's what I did. And again, if I were doing this in class on a chalkboard, I would write it out nicely, you know, so my chicken scratchings here, you have to bear with it. Okay, so now this is cool. So I want to make this a, what do I want to make this? I want to make this a 1, I guess, right? So let me see if I can figure out what I did. Okay, I sort of departed from the path here. And I did something a little bit different. But as long as I end up with row reduced form, I guess that's okay. So I'm thinking it may have been easier to take this row here and just divide everything by negative 2 and I get 0, 1, 1, 3. And that would have been quite a bit easier, but I did not do that. So what did I do? Well, it looks like I left the second row alone, and my instructions here say, oh, I understand what I did. I did the blind following the blind thing. I want this to be a 1, so I divided everything here by negative 2. So negative 2, 0 divided by negative 2 is 0, this divided by negative 2 is 1, this divided by negative 2 is negative a half, this divided by negative 2 is positive 3 halves. Okay, and then I'm over here, and I say, well, I want this to be a 1, so I just divide by negative 3, and I get 1, 1. So now it's in row-reduced echelon form, which is okay. I got the negative 1/2 here. That doesn't really bother me. As long as these guys are 1s and these are 0s, I'm in good shape. Okay, so at this point, I go back to the world of equations. This is z equals 1. And I backwards substitute. So if z is 1, I'm now going to put it to here. This is y minus a half z equals 3 halves. And I'm going to sub in. Okay. And what do I get? I get y is a 2, right? Because if I plug a 1 in here, I get negative a half, add a half to both sides. 4 halves is 2. I get y is a 2. And then I substitute z is 1, y is 2 into here, and I get x is 1. So this will be my ordered triple, a point in 3-dimensional space. Okay. Let's do number 5. And, okay, let me see if I can move this. Can I move this around? I want to try to arrange this so my head is not in the way here. Yeah, this would be better. Okay, so here we go. Looking at number 5, they're fractions, and we don't like fractions. Fractions are very likable, personally, but we want to get rid of them so our computation is easier. So over here, going to multiply by the LCD, which is 15. Don't forget this number here, 2, is 2 over 1, so 15 is the LCD. So I get 5x plus 3y equals 30. And over here, the LCD is 6, so I multiply by 6. I get 2x minus 3y equals negative 2. So this crazy tableau, this crazy set of 2 equations, 2 unknowns, clearing the fractions, I get this. Okay, so what do I do? Well, I go through the normal process. I want this to be a 1, so I divide every term by 5. So 5 over 5 is 1, 3 over 5 is 3/5, 30 over 5 is 6. And then with this in mind, I'm going to use this to kill this row. In other words, I want this to be a 0. So mentally, multiply this by negative 2, add it to the second row. So negative 2 plus 2 is 0. Negative, that's a 0. So negative 2 times, what am I doing? Oh yeah, this is, okay, multiplied by negative 2. So this is negative 6/5, right? multiply by -2. So this is -6/5 added to -15/5 is -21/5. Okay, when you add fractions, you want to have common denominator. Multiply this by -2 is -12. Add to -2 is -14. Okay, so now I'm getting closer. I got 1, I got a 0. I want to make this a 1, so I divide each term here by -21/5. Yipes. So -21/5 divided by -21/5 is 1. So I'm now having invert multiply, right? So you get -5/21 times this, -10/5, -10/3. I think I lost the sign there. Yeah, that's a -14, so that should be negative, so this should be positive. +10/3, and here we go. I get my first equation is equivalent to x plus 3/5 y equals 6. Second equation is y equals 10/3, which is nice. Substitute this back into here, backwards substitution, and look at what happens. I mean, the 3's go. 10/5 is 2, x plus 2 is 6, x is 4. So this would be my solution set. I didn't put the squiggles around it here. That's what happens. Okay, so that is the end of solving systems of equations by matrices. We're going to begin a new topic in the next series of videos called determinants, which is going to allow us to go to another method for solving systems of equations, which is pretty cool, called Kramer's rule. But we have to do the topic of determinants first. So we'll pick that up next time. And on Blackboard, if you take a look, there is going to be a problem set take-home on solving systems of equations. It's 2 problems. One is by, in fact, let me see if I can pull it up here. If I remember it, I think this is it. Okay, yes, this is it. It's got no help on the side, okay? And just a little caution here. The first problem is to use row reduction in matrices. It says show all work, do not check this matrix version, attach no additional sheets. And the second problem is the same as the first problem, except now I want you to do it algebraically by addition and subtraction and attach no additional sheets. And this one I do want you to check. So there's no point, there's one solution, it's the same thing. You just check the algebraic one, and you're not going to check this one. Okay, so those 2, and that would be due, I think, a week after. I'm not sure that the due date. It might be May 4th. Don't take my word for it. You have to look on Blackboard. Okay? All right, so next class, class 23, I believe, we'll start determinants and Kramer's rule. And hope you're doing well. Okay?